Hey everybody, it's Miss Berry. In this video, we're going to go over section 1.8, which is called polynomial and polynomial-like equations in one variable. So I'm going to share my screen and we'll go ahead and get started. Okay, here we go. So quadratic equations is going to be the focus of this section. Quadratic equations are sometimes called second-degree polynomial equations. So again, sometimes called second-degree polynomial equations. So quadratic equations, also known as second-degree polynomial equations, are equations that have the form ax squared plus bx plus c equals 0, where a cannot be equal to 0, because if a was equal to 0, it would knock out this squared term. A, B, and C, so A, B, and C are they're just numbers. They're called constants. All right, so A, B, and C are just real numbers. It's easy to spot a quadratic equation because they are going to be equations where the variable is being raised to the second power. So the highest exponent should be 2. And because that exponent is 2, and we'll learn this later on in a later section, that means that these equations are going to have at most two solutions. So we'll see that come up as we solve these. There are lots of different ways that you can use to solve quadratic equations. I'm going to go over 4 of them here. I'm especially going to focus on these first 3. This fourth one is important if you plan to go on to calculus. So if you plan to go on and take calculus, then you will definitely want to pay attention to the completing the square method that we're going to cover today. If you don't plan to go on and take calculus, I would say that this is not the method of choice for you. You would probably be better off using one of the first 3. But like I said, if you do go on to calculus, you'll need to know how to complete the square. So let's look at each one of these methods individually. First, we're going to look at factoring. Then we'll look at something that's called the square root method. Then we'll go up and look at our old faithful quadratic formula. And then last, we'll do completing the square. Now, factoring is probably the most straightforward way of solving these quadratic equations. Sometimes it's the easiest way to solve the quadratic equation. It just depends on what your quadratic equation is. Obviously, if it can't be factored, that would not be the method you would want to use. So let's look at the method of factoring. So to solve the quadratic equation by factoring, we have 5y plus 3y squared equals 12. Now, your book notes this, and it's very important, so let's write this over here. The key to using factoring, or really any of the first 3 methods, or excuse me, the methods 1 and 3, I would say, the key to using factoring is that we must rewrite the equation so that 0 appears on one side by itself. Sorry, my handwriting's so sloppy. Okay, so the key to using factoring is that we must rewrite the equation so that 0 appears on one side by itself. That says 1, O-N-E. It's kind of hard to tell. Okay. That's going to drive me crazy, so let me see if I can fix that. That's better. Okay. All right, so we definitely have some work to do over here. Another important part when you're factoring is to make sure that you write the equation in this form. So you should put your squared term first, your first degree term second, and then your constant term last. So we'll just consider that as we move everything to one side. All right, so to move everything to one side here, we're just going to subtract 12 from both sides. Okay, so that's going to cancel out on the right. And let's write the squared term first. So 3y squared plus 5y minus 12 equals 0. Perfect. So now this is in the correct form. Now we can proceed to factor the left-hand side. And then we'll use something called the zero product property to find the solution. So we'll talk about that in just a minute. But we just need to focus on the left-hand side for right now. We need to factor that. Our leading coefficient here is something other than 1. And if you notice, there's no common factors that we can pull out. So we are going to have to go over here to the side, and we'll use what we call the AC method to factor that left-hand side. So the AC method requires that you multiply the first term times the last term. So that's 3 times negative 12, which is negative 36. Now, our next step is that we look for factors of this number, so negative 36, factors of negative 36 that add to 5. You remember, we can make this little table, pairs of factors, sums of factors, pairs of factors, sums of factors. So some factors of negative 36, you could do negative 9 and 4, or 9 and negative 4. You could also do 6 and 6, but I know that 9 and 4 can give me 5. So let's go ahead and add these together. Negative 9 plus 4 is negative 5. 9 minus 4 is positive 5. So those are the factors we want to use right here. And remember, we can't jump straight to the answer right now. We have to use these factors to split up our middle term. So that 5y becomes 9y minus 4y. So 9y minus 4y. Everything else just drops down, including that equal to 0 down there. That little plus is going to drop down too. 3y squared plus 9y minus 4y minus 12 equals 0. All right, now we have 4 terms. That's sort of like something that should remind you that we can do factoring by grouping when you have 4 terms. So look at your first 2. For a minute, you just kind of put a sticky note over here, and we're just going to ignore this part of the formula. Okay, so just kind of ignore that piece and factor out the common factor out of the first 2. All right, so what's the common factor here? A 3 and what else? A 3 and a y, right? So we're going to factor out a 3y. It's going to leave us with just a y in the first part, plus, that's going to leave us with 3 here. All right, now we can uncover that second part. Sort of, for the moment, ignore. Goodness gracious, that was. I must have hit the wrong button. I don't know why that came up so small. There we go. Sorry if I'm making you guys sick with all the zooming in and zooming out. All right, so we're just ignoring that piece for right now. We're just looking at the last 2, and we're going to factor out the common factor there. What's the common factor here? A negative 4, right? So factor out a negative 4. That would leave you with a positive y. And then negative 12 divided by negative 4 would be plus 3. Okay, let's go ahead and Get rid of the sticky note. Perfect. Don't forget to drop down your equal to 0. Now look, we have a common factor here. This tells us that we're on the right track. We're doing this correctly. We got a y plus 3 here. Let's write it kind of underneath. Y plus 3 here. We got a y plus 3 here. So that means we're on the right track. So let's pull out that common factor of y plus 3, and then we'll write the leftover stuff. The leftover stuff here is 3y minus 4. So that goes in the second set of parentheses. And we are done factoring. The hard part is over. Now we're going to use that principle that I talked about earlier. It's called the principle of zero products is the official name for it. So we're using something called the principle of zero products. That means when you have the principle, or excuse me, that means when you have a product of two things and they're equal to 0, you can use this principle. The principle of zero products says that if you have two things being multiplied together and they equal 0, then at least one of those things has to be 0. So basically, you just take each piece individually and you're going to set each one equal to 0 and solve them separately. Super easy. All right, so we have y plus 3 equal to 0, 3y minus 4 equal to 0. And again, we're going to move that 3 over. That gives us our first answer, y equals negative 3. Use a different color. Better. Okay. Then over here, move the 4 over. That's 3y equals 4. Divide both sides by 3. So that's y equals 4 divided by 3. There's our second answer. So again, with quadratic equations, you will always end up with at most 2 solutions. So let me see if I can move this around a little bit so we can see the whole problem. So just to remind you what we did, we moved everything to one side. We wrote it in descending order, if y'all remember that. Then we used the AC method to factor this, which allowed us to split up the middle term, and then we had 4 terms. So we used factoring by grouping to finish solving that, or to finish factoring that, and then we set each piece equal to 0, and that gave us our 2 answers. Okay, let's look at a little bit of an easier problem. We have x squared minus 7x equals negative 12. It just shows a lot of examples here so that you could practice factoring, because we haven't done it in a little while, maybe about 2 weeks. So first things first, I got to move this 12 over. So I'm just moving the 12 over. Just going to cancel it out on the right-hand side. Okay, this should be pretty easy to factor, hopefully. We're looking for factors of 12 that would add to negative 7. I don't think I could draw a straight line on here to save my life. I'm going to make our little table. If you don't have to make the table, that's great. If you can do this in your head, then that's excellent. If you have to make the table, that's okay too. It's just totally your preference, whatever helps you. So some factors of 12, I could do 4 and 3. That would add to positive 7. If I did negative 4 and negative 3, negative times a negative would give me positive 12. But if I subtract, or if I add them together, that would give me negative 7, which is what I'm looking for. So I'm going to use those factors. And this is an easy quadratic. The leading coefficient is 1, so I know I can jump straight to the answer. So now I'm going to factor it into 2 little sets of parentheses, 2 binomials. And then I'm just going to fill in, my variable goes first, which is x here. I'll fill in my factors, which are negative 4 and negative 3. Then again, I'm going to use the principle of zero products to set each piece equal to 0. So my 2 answers are x equals 4 and x equals 3. Not too bad. That was easier than the last one. So that's the method of factoring. Again, the most important and the key part of factoring is that you have to rewrite the equation so that 0 is on one side, and you want to make sure and write the quadratic equation in descending order. That means put the squared term first, then the first degree term, and then your constant term. All right, so our second method is called the square root method. The square root method is good to use when you have an expression that's being squared on one side by itself. Let's look at how the square root method works. So here we have 2y squared equals 96. And again, the directions just say, solve the quadratic equation using the square root method. So we have 2y squared equals 96. I need my squared term to be by itself, so I want to get rid of that 2. So divide both sides by 2. It's going to cancel out on the left. All right, so what's that going to be? I feel like it's 43, but let me check. No, it is 48. Good thing I checked. All right, so we have y squared equals 48. All right, now that we've got the squared term by itself, we just have y squared equals 48. We can proceed by taking the square root of both sides. Take the square root of both sides. And you have to make sure and do the plus and minus of the side with the number. I'll explain why you have to do that in just a minute. But let's go ahead and work out the left-hand side. Squares cancel with square roots. They are inverses, so they cancel each other out. So you have y equals plus or minus the square root of 48. All right, now 48 is not a perfect square. That means that there's no number that you can multiply itself to get 48. But it does have perfect square factors. So I'm still going to come back and explain the plus or minus. So let's just finish this and then I'll come back and explain the plus or minus. But 48 does have some perfect square factors. So 48, you could break it up into 4 and 8. 4 is a perfect square. A better one to use so that we don't have to, it'll make us do less work, would be, let's see, I think it's 48 divided by 16 is 3. Yeah, so 16 and 3. So if you can, you want to use the largest perfect square factor that you can. So if it has more than one perfect square factor, make sure you use the larger of those two. My 3 got all messed up there. Let me try again. So 16 times 3. Right now, I'm going to split this up into 2 radicals. So I have plus or minus the square root of 16 times the square root of 3. That's one of the properties of radicals, is that you're allowed to split them up across multiplication. And then we have y equals, we know that the square root of 16 is 4. So that's plus or minus 4 on the square root of 3. Okay, so that is our answer. If you have to write it as like a comma separated list, you would write y equals positive 4 on the square root of 3, comma, negative 4 on the square root of 3. So that means the same thing. Either way is fine. All right, now let me explain the plus or minus. It's easier to explain if you look at a perfect square. So let's go over here to the side. This is kind of like just an aside here. So we'll say y plus or minus. So imagine we had the square root of, let's say the square root of 25. All right, so we know that this means find the number or the numbers that you could multiply by itself to get 25. So we know that 5 times 5 would be 25, but also negative 5 times negative 5 is positive 25. So that's why you have to consider both the positive and negative versions of the answer. So the square root of 25 here would really be positive or negative 5. Okay, so hopefully that helps explain why we use the plus or minus. Let's look at one more that's maybe a little bit harder. We have negative 6 times z plus 5 squared equals negative 384. All right, so again, we see we have this term, it's being squared over here, or excuse me, not term, but expression being squared. The first thing you're going to want to do is just go ahead and get rid of that negative 6 out front. So divide both sides by negative 6. Get that squared expression by itself. Going to cancel out over there. Just going on my calculator here. Negative 384 divided by negative 6 is 64. So we have z plus 5 squared equals 64. Negative divided by negative is a positive. I'm just writing the line in between, I'm writing the line in my z so it doesn't look like a 2. Now again, I'm going to take the square root of both sides. I'm going to do the plus or minus on the number side. It's going to cancel out on the left. Square cancels with a square root. So you're left with z plus 5 equals, what's the square root of 64? That would be 8, right? So plus or minus 8. Now we almost have z by itself. Last thing we need to do is just subtract 5 from both sides. Have to be very careful here. So we have positive 8 minus 5, and we also have negative 8 minus 5. So that's going to be 8 minus 5 is 3. Negative 8 minus 5 is negative 13. So there's my two answers, positive 3, negative 13. You do not have to check your answers on quadratic equations, but you can if you wanted to. All you would have to do is just plug them back into the original equation, make sure that the left-hand side is the same as the right-hand side. And that would be how you could check your answer. But you don't have to, the way that you had to for like absolute value equations, if y'all remember that. All right, so now we're at method 3, which is the quadratic equation. The quadratic equation is not always the easiest method to use, but we like the quadratic equation because it works every time. So this is the quadratic equation. It says x, or excuse me, I didn't mean to say quadratic equation. This should say quadratic formula. That's my bad. Okay, so the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where ax squared plus bx plus c equals 0. So that's where a, b, and c come from. So a, b, and c are the coefficients in the constant term in that quadratic equation. So again, the benefit of the quadratic equation is that this works every time. So if you wanted to use the quadratic formula on every single problem in this section, you totally could. This works every time. It's not always the easiest method of solving quadratic equations, but if you want to do the problems the same way every time, this is a perfect way to do that. Let's look at solving the quadratic. Look, I put equation there too. Let's look at solving quadratic equations using the quadratic formula, that should have said. So if you're using the guided notes, make sure you make those corrections. That should have said formula, not equation. So with the quadratic formula, sort of the same rules apply as with factoring. You need to have 0 on one side, and it needs to be written in descending order. So make sure you have 0 on one side, and it should be written in descending order. So let's go ahead and work on our equation here. We need to move 6 over. Go ahead and add 6 to its like term. It's going to cancel out on the right. You have x squared minus 8x plus 7 equals 0. Now, I believe, I think you could use factoring to solve this, and it would be easier, in my opinion. But let's look at how you could solve this using the quadratic formula. So go ahead and write it down. X is equal to negative b plus or minus the square root b squared minus 4ac. Oops, goodness gracious. Divided by 2a. All right, so just plug in your numbers. So here we have a is just 1, b is negative 8, c is 7. All right, plug those into your quadratic formula. So negative b would be positive 8, because negative 8 would be positive 8. Oops. Try that again. 8 plus or minus the square root of b squared, so that's negative 8 in parentheses squared, minus 4 times a times c, so times 1 times 7. Make sure that square root goes all the way over. And everything is divided by 2 times a. That's 2 times 1. All right, so let me show you how I like to do these. I'm going to pull up my document camera so you can look at my calculator. Let's see. There we go. All right. So the first thing I like to do is just plug in everything that's under the radical. Remember, that's called the radicand, with an ND, radicand. All right, so plug in everything under the radical. So that's negative 8 squared minus, oops, that's not minus, minus 4 times 1 times 7. Okay, then enter. So it's 36. Oh, that's nice. That's a perfect square. All right, so let's go ahead and plug that in. So we have 8 plus or minus the square root of 36 over 2 times 1 is 2. All right. I have to move that down some. All right. Okay, so we know that the square root of 36 is 6, so let's go ahead and write that in. So that's 8 plus or minus 6 over 2. Now I'll just go ahead and split it up into 2 pieces. 8 plus 6 over 2 and 8 minus 6 over 2. 8 plus 6 is 14. 14 over 2 would be 7. So that's our first answer. 8 minus 6 is 2. 2 over 2 is 1. So that's our second answer. 7 and 1. All right, so that was how we use the quadratic formula to solve a quadratic equation. All right, let's do one that's a little bit harder, and then we'll complete the square. I'll show you how to complete the square and we'll be done. All right, so quadratic formula. Everything's on one side. Sweet, we don't have anything to do here. We can jump straight into the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. All right, so in our example, a is negative 2, b is 2, and c is 7. So negative 2, 2, and 7. So let's plug those numbers in. Negative b would be negative 2 plus or minus the square root of b squared, so that's 2 squared, minus 4 times a times c. So 4 times a, which is negative 2, times c, which is 7, all over 2 times a, which is 2 times negative 2. All right. So let's take and plug in our radicand into our calculator. We have 2 squared minus 4 times negative 2 times 7. So that's 60. That's not a perfect square, but that's okay. It's okay if you don't get a perfect square. So we have negative 2 plus or minus the square root of 60 over 2 times negative 2 would be negative 4. Before we go ahead and split this up, let's go over here to the side and simplify the square root of 60. Think about 60. Are there any perfect square factors of 60? So I'm just going to pull up my calculator, say maybe 60 divided by 4. That works. So 15 times 4. Let's just make sure, see if 16 goes into 60. It does not. Maybe 25. No, it doesn't. What's our next one? 36. No. Okay, so we'll go ahead and go with 60 times, 15 times 4. Right, so go ahead and write your perfect square factor first. 4 times 15. So that simplifies. You could break it up into square root of 4 times square root of 15. So that would be 2 on the square root of 15. Right, so go ahead and write that in. That's negative 2 plus or minus 2 on the square root of 15 all over negative 4. Okay, we're almost done. The only thing I see here, let me move this down a little bit. Sorry. The only thing that I'm seeing here is that I have a common factor in the top. I could pull out a 2. So let's do that. All right, so I could pull out a 2 in the top. That would be negative 1 plus or minus 2 divided by 2 would be 1. So 1 on the square root of 15. You don't have to write the 1. I know I keep getting more and more slanted. Let's see if I can write that a little bit straighter. Sorry, guys. Negative 2 plus, excuse me, I'm supposed to be factoring out 2. Negative 1 plus or minus. You don't have to write the 1 on the square root of 15. It's just understood to be there. All over negative 4. And the reason I wanted to factor out that 2 is because I could reduce it with the denominator. So 2 over negative 4 reduces to just 1 over negative 2. So that would reduce to 1 times negative 1 plus or minus square root of 15. So I don't need to write the 1 out front. Again, I'm getting more and more slanted. Negative 1 plus or minus the square root of 15 over negative 2. Okay, and this would be fine for your answer. If the homework wants you to split it up and write it as a comma separated list, you could write it as negative 1 plus square root of 15 over negative 2, and then negative 1 minus the square root of 15 over negative 2. So again, this would be called a comma separated list. But this is fine for the answer. Okay. Either one of these are the same thing. All right, so our last method of solving quadratic equations is called completing the square. Completing the square is not the most efficient way to factor a quadratic equation, but like I said, you do have to know how to do this in calculus. So if you do plan on going on to calculus, you should make sure and write these steps down and just try to get a grasp of what's happening here. All right, so step 1 is to write the equation ax squared plus bx plus c equal to 0 in the form ax squared plus bx equals negative c. So basically move the constant term to the right-hand side. All right, so that's what you're doing there. Move constant term to, I'm going to abbreviate here, right-hand side. So move the constant term to the right-hand side. Divide everything by a. So that the coefficient of x squared is 1. So basically, if you have a coefficient on x squared, divide every term by that coefficient so that you've got a coefficient of 1 on x squared. Then you're going to go off to the side, do a little bit of scratch work. You're going to divide the coefficient of x, which we're going to call the middle term. So divide the middle term by 2, square that number, and then add it to both sides. Then the trinomial on the left will now be a perfect square trinomial, and then you can go ahead and factor it, and then use the square root method from there. All right. So let's look at this first one. We'll start off with an easy one, and then we'll look at one that's a little bit harder. See if I can lock this down so I don't move it. There we go. All right, so solve the quadratic equation by completing the square. All right. So right now you can see that our coefficient on x squared is 1. So it works out for us that we don't have to worry about dividing. Well, sorry, I actually skipped the first step on accident. Let's go ahead and move that constant term over. That was my bad. Go ahead and subtract 63 from both sides. Move that constant term over. All right, so we get x squared plus 24x equals negative 63. Okay. Now again, your next step is to look at your x squared term and you say, okay, is there a coefficient other than 1? There is not in this case, so we don't have to worry about step 2. But say that we had something like 2 in front of x squared there, we would have to divide everything by 2. But here we just have a coefficient of 1, so we don't have to worry about step 2. Step 3 is to take your middle term, quote unquote middle term, go off to the side, do a little bit of scratch work. So take your middle term, divide by 2, take your middle term, divide by 2, and then square that number. 24 divided by 2 is 12. 12 squared is 144. So you're going to add 144 to both sides. All right, so then we have x squared plus 24x plus 144 equals, let's see, negative 63 plus 144 is 81. Perfect. Right now, the directions, if you remember, they said, at this point, the trinomial on the left side will now be a perfect square trinomial. So that means it's every time it's going to factor into what they call the square of a binomial. Okay, so here is the little trick that you can use on the left-hand side. Each time it's going to factor to something that looks like this. You have your variable first, then you have a little blank space here, and it's going to be something squared equals whatever the right-hand side is. In this case, it's 81. Now this number here, this piece right here, it's going to come from right here. So it's whatever you got when you divided your middle term by 2. So in this case, it was a positive 12. Okay, so that gives you x plus 12 all squared equals 81. Now we can use the square root method to finish solving this. So take square to both sides. Make sure and do the plus or minus on the number side. It's going to cancel out on the left. Square cancels with a square root. We have x plus 12 equals plus or minus square root of 81 is 9. Go ahead and subtract 12. Remember, you got to be careful doing this. You get positive 9 minus 12, and then negative 9 minus 12. So you got to do both pieces, the positive and the negative. All right, so that's negative 3. That's our first answer. X equals negative 3. And then this is negative 21. There you go. So x equals 3. Again, you could write it like this. X equals negative 3, negative 21. I think I said 3 there for a second. Sorry about that. So that, again, would be called a comma-separated list. Okay, so let's try that one more time. On the homework, if you have any questions that say solve the quadratic equation by completing the square, you don't have to use the you don't have to complete the square. You could use quadratic equation. You could factor. So use whatever method you want. You don't have to complete the square, but you should. If you plan to go on to calculus, you should practice this. All right, so we have 3z squared plus 18z minus 273 equals 0. We're going to complete the square here. So we start by adding the constant term, moving it to the right-hand side. It's going to cancel out on the left. So you have 3z squared plus 18z equals 273. All right, step 2 says to divide by a so that the coefficient of x squared, in our case it's z squared, is 1. So divide everything by the coefficient on your squared term. You'll cancel out right there. So you have z squared plus 6z equals, see that's 91. Just make sure 273 over 3. Yeah. All right, perfect. Now, we are to step 4, which says the trinomial on the left-hand side will now be a perfect squared trinomial. Oh my goodness, I'm sorry. I forgot to do step 3. Y'all, I'm sorry. Let's go back and talk about what we just did. We just divided everything by the coefficient on the squared term. That was step 2. Step 3 is where you go off to the side and do that scratch work. All right, so take your middle term, go off to the side. Remember, you divide it by 2 and then square it. So 6 divided by 2 is 3. 3 squared is 9. I'm going to add that number to both sides. Plus 9 plus 9. So you get z squared plus 6z plus 9 equals 91 plus 9 is 100. Okay. Now this is a perfect square trinomial on the left-hand side. So we have a perfect square trinomial on the left-hand side. We can write that as the square of a binomial. And remember what I told you. The little trick here is that this can always be written as variable first, then a blank space, squared equals right-hand side. All right, so this number here, use a highlighter this time. So this number here comes from right there. So it's whatever you got when you divided the middle term by 2. So that's going to be a plus 3. Okay. So right now we have z plus 3, all squared, equals 100. Go ahead and take the square root of both sides. Don't forget to do the plus or minus on the number side. Okay. Let me scoot my page down. On the left-hand side, the square cancels with the square root. You're left with just z plus 3 equals plus or minus. Square root of 100 is 10. Then we're going to subtract 3, subtract 3. It's going to cancel on the left. So we have z equals positive 10 minus 3, and z equals negative 10 minus 3. So that's 7 and negative 13. And again, you could write it as z equals 7 comma negative 13. But however you want to write it. This is probably how I would write it on the test. That would be how I write my answer choices on the test if it was multiple choice. All right, you guys, that's everything for section 1.8. Section 3.3 is sort of similar to this section. It uses a lot of stuff from this section, so we will see it again in the next section if you need more practice. But until then, I hope you guys have a great day, and I will see you soon.